Ohio. All right. So looking at this, right? Yeah, you're picking up what I'm laying down. Cool. So yesterday we were talking about vertical air circulation, and we're looking at the tropics. So between 30 north and 30 south, as far as degrees latitude are concerned. As we look at it, I erased a picture that I had a moment ago, but we have our planet, and we have an atmosphere. Now, near the equator, between this 30 degree mark up here, 30 north and 30 south, you get the tropics. Now, that's not to scale at all. But remind me again, sunlight hits the tropics at close to what angle? 90 degrees, which means most of that light just absorbs into the ground. Not whether it's most of it or not is beside the point. Not much of it just glances off. Okay, when we look at this then, we spoke about it yesterday. I'm not going to draw the atmosphere right now. The air that's here, when the sun hits it perpendicularly, what happens to the air?
It rises.
Air rises, heat rises, right? There's a reason that air conditioners are put up high and heaters are put down low. Heat rises. So as we're looking at it, let's assume that we have air here. I have air that's been heated and it starts to rise up. Everybody okay with that?
Yeah.
Now, we use this basic idea over at the hatchery, a little bit different, but same concept. When that air rises, it leaves a void behind. Would you agree with that? When the hot air at the equator rises, there's now a lack of air underneath of it because all that hot air just left. What fills it in? So like if I take this air, you're right. If I take this air and I move it, and I did, you couldn't see it, but I did, more air had to come in to fill that void, right? Do you guys agree with that? So what we inevitably see happening in this situation is this air rises, so heat rises, nothing crazy there. And then something has to flow in to replace it. Now, the air's not going to come from the equator because that air's hot. We're going to have to pull air in from here and from here. Replace. Everybody cool with just that basic concept? Hot air rises, air must flow in, and the only place it can come from is, in this picture, between like 30 degrees north and south. Air comes in to replace it. Now, this is only one perspective of what we're looking at, though. Now, we're looking at the globe like as the atmosphere is right here, which that's all fine and dandy. But let's look at it a little bit more. When this air rises, surely this must pull different air, and we start to get things that look like this. Wrong direction. Like eventually that air rises, it starts to cool down, and this cycle just repeats, right? What we see here are these cycles or these currents that happen all over the globe. These are known as convection currents. When you have hot air rising and then cold air rushes in and then it gets heated and it just cycles, we have two convection currents on the board right now. So I'm just going to label a little thing here, convection current. Now, for convection stuff, if you have a fancy oven at home, you might have a convection setting on it that pushes air throughout your oven to make it heat more evenly. It might be called roast. Air fryers utilize this as well. The water in a pot of water as it starts to boil does exactly this. The water at the bottom of the pan gets hotter because it's touching the metal that's touching the heat. It rises, cold air from the top comes in, and it just starts to do this cycle, which is a big rolling boil eventually. Nothing crazy happening here yet, I don't think. Questions about this convection before we move on? You guys have heard the word convection before, correct?
Yeah.
Okay, cool. Now, we're going to switch perspective. We're looking like at the Earth as I'm just looking at the atmosphere as a whole. But let's look at it from a different perspective. As we move and look at this instead of just looking at the atmosphere, I'm going to try my best to draw a globe, at least roughly. There's my equator. Now, that's not very circular when I look there. Okay, there's another action that's happening. As we look at the globe, and there's my lovely equator. Let's think about what's happened with this air. Now, I can't draw it nicely from this because I'm not that great at 3D, but the picture that we just drew said air gets hot and it cycles like this. And then that cold air fills back in. That's the picture that we have above, and this is the perspective that we're looking at. Now, I want us to think about just this little region as we look straight at the planet. The air that was here at 30 degrees north must go what direction? Does it go south from here at that 30-degree mark, or does it go north? If this air has to follow in, and this is this picture, if this is 30 degrees, that air then moves toward the equator. Do you see that in the picture? Okay, everybody know that before I said it? The air must come toward the equator because the way that that cycle's running. Everybody okay with that? Now check this out. This is going to tie together with what we talked about with the Coriolis effect. I then have air from 30 degrees in our piece that's doing this. And it's working its way back toward the equator. Everybody agree with that? Okay, if you have notes, it's going to be a little bit easier. If we're working toward the equator in the north hemisphere, the Earth still spins, which means we get the Coriolis effect to work in this picture as well, just like we did when we said we're traveling on the globe. Which way does this air right here, as we're moving toward the equator, which way does it deflect? To the left. Now, you mean like this. Okay, and this one does the same thing that way. Now, as we look at it, remember, we're talking about air right now. Bless you. This is going to happen all the way around the planet, which means if we wanted to add this back in, we're going to see this happening everywhere on our planet. Now, all these purple ones are on. Sorry, I'm losing my thoughts. I'm trying to do this to the right direction looking stuff. Okay, all of those are in a similar region between 30 north and 30 south on our planet, and this is how the air winds up moving because it's been adjusted due to the Coriolis effect. As we look at this, is there a lot of ocean on our equator? Like if you imagine the Earth, the equator, there's oceans around a lot of it. You run through almost like a lot of continents, but there's a lot of stuff. Have people historically needed to travel on the oceans? If you don't have a motor, how do you get around? You sail. And what do you need to sail? We just saw that air rises, cools down, falls, and then blasts its way back to the equator because of that empty space that was left. We've just discovered our first winds. What are the winds around the equator? What are they referred to as, geography people who have all taken geography? Why did Columbus sail? He didn't just sail for glory, right? Like I'm sure that's part of it, or to absolutely destroy a culture simultaneously. But that wasn't his main purpose. They were trying to find a route to trade spices. These have a name that relates exactly to that. These have been used throughout time to trade between countries. These are our trade winds. We have just discovered our trade winds. Not the apartments, but the literal trade winds. Now, these winds, our trade winds, do they blow from the east or do they blow from the west? Not rhetorical. Talk with your neighbors. Based on this picture, assuming that up is north, which way are those winds blowing from and to? From east to west. Do you guys agree with that back here? They're moving from the right to the left. That's east to west, right? These could be called the tropical easterlies if you wanted to get crazy about it. These are easterly winds. Easterly. Oh boy. There's probably an R. That looks wrong when I write it. Is that wrong? Does that look like a real word to you? It does not to me, but that's all right. Easterly winds from... No, easterly. I don't know. 30 degrees north to 30 degrees south. Okay. As we run through here, there are some other things that are going to start happening. I want you guys spend a moment. It's going to take a couple minutes. Without your books, if you need a globe, I'm fine with it. But I want us to think about this next section. So here's all of our tropical easterlies, or the trade winds. I want us to kick up one little spot. So by that, what I mean is at your group, logically try to justify it. I want to look between 30 and 60 degrees. So here we have all of our tropical areas that we just covered. And we know that the winds blow from the east to the west. They're easterly winds. I want us to look now between this 30 degree and 60 degree north or south. 30 degree, 60 degree. And I want you guys, using similar logic that we worked out here, let's try to think about what happens with winds in this range. I'm going to give you a couple minutes. I don't care if ideas are bad. If it's about this, I'm going to say there's no true bad ideas, but I want to hear you guys talking and trying to reason it out. Cool. What way should winds blow on our planet in that next little range? That's the question at hand. Couple minutes to chat it out with one another. I will be eavesdropping on all of you. Cool. 30 to 60. So we did 0 to 30, either direction. We saw that they blow from the east to the west. My question now is, with this idea of convection and heat rising and all this, how are the winds going to blow in this next step up? Cool. I'll give you guys a couple minutes. Discussions. If you need a globe, I will hook it up. But I want to see what you guys come up with first. So Holloway lied a little bit to you, because the part of the picture, if you've already discussed, that you didn't get to see, is when this air hits, it doesn't all just go straight south. It splits. Just like if you were to pour water on a table and it goes left and right, the same thing happens with air. Cool. I'll give you a moment, and then resume this when you're ready to talk about this 30 to 60. Cool. As I look at the wind moving north, which way is it going to deflect? To the east, which means we just discovered a beautiful second wind pattern on our planet. In this section, we get a change. We start to have winds doing this. Okay, it is a result of two different pieces. It is a result of the air coming back down and the fact that we are working on a spinning reference frame, and we have to account for that. That's really fancy way to talk about the what effect? Coriolis. So as we're looking here, I'm going to label mine a little bit more clear. We saw that we had in this section, what were they called? The trade winds. So we get the trade winds right here. Okay, up here and here between 30 and 60 degrees, 60 and 30, we saw the wind moves the exact opposite direction. So I'll do 60 degrees here again. Okay, these, are they blowing from the west to the east or vice versa? They're blowing west to east. These are known as our westerlies. Not westerlies, but the westerlies. Because again, when we talk about wind, it's the direction from which it comes. Northerly winds come from the north. Westerly winds come from the west, which implies that they must blow east. Okay, we have one more little piece to look at here. We get one last little piece, and this is going to be the last thing that we do today. I want us to consider our last, and that's not to scale. We went 0 to 30, and we saw with the trade winds. We went 30 to 60, we saw the westerlies. What's the last little regions?
Northerlies and southerlies.
So we're on the north and south pole. I like where your head's at, but there's more to it than that. This one, same thing. I'm going to give you a minute. See if we can't logic out which way do you think the wind is going to blow here. I'm going to give you a moment. Talk it out. I bet the logic that we used on the trade winds might still apply.
Oh, it's going to go up that one.
Cool. We're going to go in 5 minutes. So let's finish this part up, and we'll head over to the hatchery. Talk it out. Remember, our Earth is tilted. It's really hot or really cold at the poles? Cold. That's a good thought. Is the air warmer here, you think? Is it warmer right here than it is at the pole? I would probably use that to think about this. I'll give you just a moment. On our planet, we're almost at 60 degrees. We're almost there. Do you think the wind that, or the air that comes from the south or the air that's already here is warmer? Let's say that I could right now take the temperature at this part of our planet, and I could take the temperature at this part of our planet. Where's the air warmer? The bottom one, because it's further south, near the equator. Now, logically, it would stand to reason then that this air that's coming from the south is a little bit warmer than the air that's already there. Okay, we're going to see something very similar happen. Now, I didn't draw the tilt of the Earth. Where do we get more direct sunlight still, though? At the pole or here? The lower part, because it's less tilt and you get less of a deflection, right? So if I'm trying to hit Can I steal your glove for a second? We're going to do it on this one. I'm going to be upside down, I'm pretty sure. Hello. Oh, getting crazy. All right, so here we have our planet. Eventually, weird, I'm trying to work like backward on this. We're getting some nasty glare. Can you guys still see it okay though? Okay, we have the globe that's really tilted like this. Like it's pretty tilted. If I'm looking at it, I get more heat right here than I do here, because if it comes from this way, it's going to glance off and just bounce. Whereas here, it's going to still bounce, but more energy is going to be kept on the planet. Cool with that. Okay, what we've just highlighted then is the air right here gets more heat added to it than the air up here. Everybody good with that? Now remind me again, because we talked about it earlier, what does hot air do compared to the cold air?
Rises.
It rises. So you do not have to include this whole picture again, but I just want to show you. This air is warmer. It's going to rise. Okay, when it rises, cool air must fill its spot. Is the cool air going to come from the south, or is the cool air going to come from the north?
It's going to come from the north.
It'll come from the north here because the North Pole is colder, which means we're going to get a bunch of air coming down this way, and it means that if that got left, this air eventually has to work its way up like this. We get another big convection current up on our pole. Now, this is looking from the side perspective. What I see looking at the planet is I'm going to have air coming from here toward the equator because it has to fill that gap. Which way is that going to deflect again?
To the right. I'm to the east.
So careful. Deflecting, and this is where the language is weird, right? The air is going to deflect to the west, is how I would say it. Just like this air deflected to the west, because if I looked up, I went to the west. We're going to see almost the exact same patterns up here that we saw near the equator due to that same reason. There's no more momentum getting stuck in here to keep this rolling. The cold air and the convection currents win this fight. Okay, this happens at the North Pole and the South Pole. We can say then this happens at the poles. Everybody cool with that? Does it move? Are these easterly winds or westerly winds? Easterly. We have just seen our last major air pattern on our planet. We have up here between 30 and 60 degrees what are known as the polar easterlies. Now, this is why the easterly as a singular was so weird, because every time I've ever seen these words, it's been in this plural form. The polar easterlies. We range not from 0 to 30, not from 30 to 60, but where? 0 to 30 is this range. 30 to 60 is this range. What's this last bit? 60 to 90. 60 degrees north to 90 degrees north. Now, within each of these, obviously this does not hold true all the time, constantly, because we have weather on our planet that changes this. These are the basic weather patterns, and I think this is a good spot to pause. Cool. Random question for everybody. I know that Columbus or Magellan, whoever you want to look at, when they sailed, they left Europe. Do you know where they landed initially anyway? It was like the Bahamas, down in the Central and South America. Okay. They went back to England. I don't know enough about sailing, and I just don't know the answer off the top of my head. Just food for thought for you guys. They did not sail around South America to get back to Europe. They sailed back across the Atlantic. How do they get around the trade winds to sail east if the trade winds always blow to the west? How does a sailboat function going that direction against the wind? I don't know anything about sailing though.
Maybe you just you ride the westerly as far as you can, and then you take a turn up.
Yeah.
You think it's impossible to sail? And I don't know the answer. This is just random thought that I'm having. Could one sail on the equator across the Atlantic to Europe?
Wind blows different directions even on the equator.
For sure, it does. These are global patterns, and I assume that it's the weather patterns that they wind up taking advantage of. There's got to be a stream in here somewhere to follow.
Math and science are
Indeed. Cool. All right. This is your intermission. Cool. Stuff to study for math if you need it. We're going to I'm going to rework the way that we clean trays because they've all been moved. Do you guys know your numbers? Do we still know our numbers? I left the sheet over there at the hatchery the other day. So check it out. Keisha's going to help me organize this over there. Everybody's just going to get a number, regardless of whether it's your tray or not. You're going to have a spot that if there's a tray there, you're going to clean it. We only have like 2 more weeks of cleaning these, and then we'll be in the big raceway anyway. Now's your chance. Go grab your stuff. Go to the bathroom. We're going to go over to the hatchery and do some work real quick. Cool. I'm not going to end this because we might record more. I don't know for sure.